Good afternoon, everyone. We're going to speak in English because part of the research team is not Brazilian. And welcome to our Tech Hour. For those who don't know me, I am professor at the Department of Sociology and also researcher here at the C4AI. And today, I am super happy because we are receiving this research team. I know part of them 2 months ago in Portugal in a congress of ethics and AI. And when Nicholas told me about their project, I was blown away by what they are doing with text generation in Portuguese. Nicholas is Brazilian, which helps when dealing with this kind of work, but the rest of the team is not. They develop a model called Tucano. I won't say anything about it because they're going to present in the next hour. But I will represent the team. So Nicholas Kluge is a postdoc researcher at the Center for Science and Thought at the University of Bonn in Germany. And if I may mention Nicholas, Nicholas was also one of the founders of the Brazilian branch of IDES, which is the AI Robotics Ethics Society, which is an initiative originally established at UCLA. Aniket Singh is a researcher at the High Performance Computing and Analytics Lab. And also she's a researcher at the Helmholtz Institute for Strahlen- und Kernphysik at the University of Bonn. Sophia Falk is a PhD candidate at the Bonn Sustainable AI Lab at the University of Bonn. And the last but not the least, Shiza Fatma is a master's student at the Institute for Computer Science at the University of Bonn. So you have like 50 minutes. You can present. I don't know if you have some presentation to share with us.
Yes, I have.
So take your time. We're gonna record this meeting, and then probably will be available on our website, right? On our YouTube channel, right? So, okay.
Hey everyone, is my presentation showing up good?
Yes, perfect.
Okay, so you already saw my first slide. Preprint, you guys can accompany everything that I'm going to be saying if you check the preprint, and you can also find our GitHub and our Hugging Face. Everything is available online. So what are the motivations of our study? First of all, maybe you guys already know, LLMs became artifacts of interest recently. And now it's commonly accepted that, like, you know, through the vastness of our available unlabeled data, we can develop these foundation models, and they are quite useful for a lot of downstream applications. There are entire tech companies, and there's a lot of money invested on these things. I don't have to cite all of the models available today. So in short, they are interesting things, and there's a lot of research happening around them. Who would have thought, like, I don't know, in 2019 when I started doing research with these things, that they would become what they ended up becoming? Certainly not me. But also, you know, this thing that, like, through these models, we can leverage the vastness of available unlabeled data at our disposition to train them. But this part of leverage the vastness of available unlabeled data, while it is true for some languages, like you can easily find like a trillion token data set for English and Chinese. You don't find these things for like most of the other 7,000 languages that exists on the world. So these resources, they are not distributed like in an equal way, which is understandable. But, you know, if these things are such artifacts of interest, it would be nice if it were more efforts in trying to make things a little bit more fair in terms of resource distribution. Also, we, in our research and the research that we have been doing, like we are, at least I can speak for myself, I think that multilinguality is not enough. Like there are several papers that use this model, like that the multilingual is not enough. and it's constantly being shown that like if you think a multilingual model that was trained on trillions and trillions of multilingual text, trillions and trillions of tokens of multilingual text, and you compare them to a monolingual model trained on much less tokens, but specific for a domain, specific for a language, usually these monolingual models, they outperform the multilingual. And to me, there are very intuitive explanations to why this happened. Like it seems sound to me. And also a couple of the experiments that we ran also show this, that like multilingual models, they usually underperform monolingual if you have sufficient data set, if you have a sufficient amount of tokens to train the monolingual ones. Okay, and another motivation that we had is this idea that we want to try to escape technological colonialism. Because right now, I don't know if many of you feel or see this. I think that like most of people who are part of like communities and cultures who can be characterized as like low resource languages, they are very happy, like, you know, waiting for the next Llama to be dropped. Then we fine tune them to our domain with a bunch of Portuguese text, and then we're happy. And I think this is unacceptable. And I know other researchers who also think that like this is unacceptable. If these things are such artifacts of interest, it has to be unacceptable the fact that there's only a couple of companies who first know how to build them and have the resources to build them. You know, monopolies are not good, and for several reasons. And we could go right now into a sociological tangent that I will try to avoid right now. But I'm basically gonna start from the presupposition that this form of monopoly, or as I put here, technological colonialism, it's normatively not desirable. So we want to try to escape that. Another motivation for our work. And okay, now these are basically the motivations, the things that inspire us to start doing this kind of work. Another thing, like one of the things that I think is really cool that you're going to find in our paper, it's, I think, if I'm not mistaken, is our second section. It's called An Ontology of Portuguese LLM Development. I've been outside of Brazil for already a couple of years right now, so I'm a little bit outside of the current trends and talks and gossip running around Brazil. But after I published this paper, we had an amazing feedback from the community, and so many people have been nice to me, nice to my colleagues, and have been coming to talk to us. And during this talking, I learned about so many things, of controversies and discussions about, like, you know, things like, for example, people debating about the need for a Brazilian, or let's say a Portuguese AI, or what is the first Brazilian Portuguese foundational model. And we didn't know about all of this controversy, but one of the things that we tried to do on this paper is because we see a lot of confusion in the literature, a lot of confusion regarding like, is it a pre-trained model? What is extended training? What is continual learning? What is the difference between these things? What is the difference between extended training and fine tuning? So we wanted to write a section about, like, you know, history of LLM development for Portuguese, to try to promote like deconfusion, like, you know, because there's a lot of confusion going around, especially on popular discourse. And, you know, and like we were able to capture a couple of trends. I also wanted to say something. I think this image is really nice because it shows that like we have been developing LLMs for quite some time. Like, you know, first fine-tuned Portuguese LLM in G Portuguese by the true GOAT, Pierre Guillot. Like we have Bird Timbau, which is the complete GOAT for Portuguese, such a useful model. There's so much work has been done in Portuguese on the past couple of years, and more so aiming at text generation, like, you know, GPT style decoder-transformers. And there's a lot of good work out there, a lot of good work. And I would say one of the things that I wanted to say on this part of the presentation, you know, if you like the question of like, what was the first foundation model? What was the first fine-tuned model? It's not a question up to debate. It's empirical. You can just go into the repositories, and if they are public, they are open. They have git commit histories, and you can just check who one did first. And it's not a question up for debate. It's interesting why people debate about these things, about other reasons, like why marketing sometimes is push in an untruthful manner, because marketing has no, they have no ties to being empirically or epistemologically correct. And those are interesting things for philosophers and sociologists. But in terms of what it actually is, I think for anyone interested in doing the research again, and going to check all the dates of these repos and reports and when they were published, you're going to find probably the same timeline we found. And if you found some discrepancy, you're welcome to publish it. But there's a lot of good work happening, and a lot of things that led us to the point that where we are now. And I would like to point to some insights and trends that we were able to perceive when we did this, this literature review. First of all, most Portuguese LLMs develops are the result of fine-tuning. And on our paper, we define fine-tuning just like all books of deep learning define fine-tuning. And that's completely understandable because it's a more easy approach. Fine-tuning models is much easier than pre-training them, and is also require much less resources. And is an awesome approach. It works. It's really cool. But sometimes there are a lot of problems with the fine-tuning approach, because sometimes you have to use things that were developed no one knows how they were developed. You don't know what is happening behind closed doors. I think there is an argument to be made that if you want to do science, if you want to do research, it's very important that research is reproducible. It has to be. That's one of the epistemological foundations of science. And if a big chunk of your research is irreproducible because you build your model on top of a foundation that there's no way to reproduce because data is not available, training methods are not available, you get this whole, there's no way anyone will ever be able to reproduce what you did from the ground up. And that's a problem for many reasons. And also another thing that we found that a Portuguese is not mature enough that we have a common benchmark or protocol for evaluation. Most of our evaluations are sui generis, which means that they are almost every paper comes up with their own evaluation method, and then comparing results, it's a nightmare. It's really hard. On our paper, all of the benchmark results that we show, we did all the benchmarking again, just so we could make, because on English, usually people use we are comparing our results to the results of that other paper. So they don't have to compute everything again, because they are quite, for many research, they're quite sure we can trust those results because they use this standard library. They made available their the hyperparameters that they use for evaluation and sampling, so it becomes more easier. In our case, that's not the case, and that makes research a little bit difficult. Also, evaluations may not be effective. A lot of the evaluation benchmarks currently available for Portuguese, they are not benchmarks made for evaluating text generation models. They are usually benchmarks that were made initially for evaluating BERT style models. And if you're gonna compare, when you see the benchmarks that we use for Portuguese and benchmarks that I don't know, that the famous benchmarks, they are famous benchmarks used in English, they're very different. It's very different. And so there is no, and there also there's no research being done to evaluate how our evaluations are effective. Is the ruler that we are using to measure actually good at evaluating Portuguese language modeling? Another hopeful and very cool trend is that our data sets, our open data sets, have become slowly getting bigger. This year, on 2024, researchers like Eduardo Garcia, for example, from the Center of Excellence in AI, he released a data set which is called CrawlPT, which, if I'm not mistaken, it was around 200 or 300 gigabytes of Portuguese text, and that was a huge data set. And he put a lot of effort into duplicating everything, filtering, and putting everything out there. and that's a commendable effort. And from our Portuguese European brothers, they also released some cool data sets. Like, for example, Gloria was trained on, if I'm not mistaken, 30 billion tokens. And it's a fully open source model based on GP2 X architecture. So a lot of, like, we have slowly become like we have slowly started to scale Portuguese LLM development. Also, one of the things we saw, like when you have these large data sets, filtering becomes a challenge, and like an absence of, like, filtering pipelines available, like open source, just for Portuguese. We most of the pre-processing that we saw from works like Eduardo Garcia or other papers, they usually use like these heuristic-based filters that we also use in our paper, like, the classic the classic set of rules of, like, how to discard text that is not good, that is too short, that is broken, but nothing more sophisticated like learn filters, where you can actually, like, judge a quality of the text based on something that is very hard to put on heuristics, but it's something that, like, for example, a language model can help you do it. And also results showing that, like, pre-training has as starting to see that is like it's also a promising approach. Like, again, citing Eduardo Garcia, he published a paper on the development of a Roberta model specialized for the legal domain. And he compared a pre-trained model that they did with a fine-tuned model, which is Bertimbaú. Bertimbaú was fine-tuned from multilingual BERT, and their model was outperforming them. So, among other studies showing, like, pre-training, when you have sufficient data, you can outperform fine-tuned models, especially when the fine-tuning promotes this drastic shift in distribution, a drastic shift from, like, English to Portuguese. That's a humongous shift in distribution. So yeah, these are the things that we can know about, like, trends and insights. Maybe there are others. I'll recommend you guys to read that section of our paper. I think is really cool. And from all of that, from those motivations, from, like, gathering the insights from the field and seeing, like, the deficits, there's not much of this, maybe we could try to do something like this, we develop our study. And the main deliverables of our study is basically a concatenation of larger and more high quality data sets for Portuguese, which we call GigaVerbo, the development of some of the first learned filters and data sets to improve text pre-processing for Portuguese. And we also were able to push self-supervised pre-training beyond the 500 billion tokens mark for Portuguese, or meaning we pre-train natively Portuguese language models on 500 billion tokens, and this has not been done so far in the literature. And also we promoted a critical assessment and comparison of the benchmarks that people currently use. And, there are leaderboards built on top of these benchmarks, and we are all act like they mean something. It will be interesting to see if they actually mean something when we are using them to, evaluate something that was trained just on Portuguese. So first of all, GigaVerbo, what it is, GigaVerbo is a data set, is on Hugging Face, everyone can download it. We were basically copy like other studies. Many studies, they do this approach of, like, trying to gather all available data sets that they follow, concatenating them, deduplicating them, filtering them, and promoting something. Like the pile is an example, like Crawl PT, the data set from Eduardo Garcia, is also an example of that. We did the same, and we ended up with 145 million documents amounting to around 700 gigabytes of text. That's equivalent to the pile. So, we are basically 4 or 5 years behind what people are doing in English. Five years behind, 4 years ago. Like, Llama AI, they published the pile, and it was an awesome data set. They used to train Pythia, which are, like, one of the only suits of truly open, reproducible LLMs. Is a commendable effort. I love Llama AI. They're awesome. And we tried to do the same. Like, this is can be like this could be like the pile Portuguese, what we call GigaVerbo, because GigaVerbo only. We also, some recent studies, they have showed that, like, that size is not all you need. Like if you have a huge data set and most of your data set is junk, you're probably not going to get very good language models out of it. So there's a lot of effort in not just scaling data set size, but also making the text present on the data set more high quality. Because enhancing data set quality instead of just scaling data ingestion and model size gives you like actually from a sustainability perspective, like, thinking about energy consumption is actually gives you more bang for your buck. And that's quite interesting. But defining what high quality is for arbitrary text is not a trivial question. So one of the things that we employed in a study, which is nothing novel, was already done on other studies. I will cite Textbooks Are All You Need, which is a great paper that all the phi models came from this research effort. And they use a very simple approach to filter, like, to create a synthetic data set and also to filter it. They use GPT-4 as a judge. And we did basically the same. We took GigaVerbo, we took 110,000 samples from 9 subsets of GigaVerbo. What are these subsets? You can go check the dataset card, is on Hugging Face. And we asked GPT-4o to evaluate all of these texts and gives us a score. And we use this classification/regression data set to train our own filters, because using GPT-4 to filter 145 million documents is like, we didn't have money for that. So we train our own filters, and all these filters, they are available. They are all available on Hugging Face, and you can download them. And also, GigaVerbo, the way that it is right now, it already comes with the label of our filters and the class confidence. So, if you don't trust our filters, you can basically drop those columns and use GigaVerbo as it is. Or if you don't like approve the way that we filter our data set, removing every low quality sample only if class confidence was above 95%. If you don't agree with that, you can do your own filtering. Like you can, but if you want to reproduce our study, these were our settings. After filtering, we removed 30% of GigaVerbo. We remain only with the remainder, and that is what we use to train our models. And we also, like, with this remainder of GigaVerbo, we scaled it according to what is called data constraint scaling laws, which is from a paper from Hugging Face that they show like what is the optimal amount of epochs or token repetition that you should use for, like, when you don't have enough tokens. And based on these, we scale our data set. And the scaling factors you can find in our paper. I'm sorry if I'm passing too much details and always saying like, is in the paper, is it on Hugging Face, but that paper has 35 pages. It's very big, and I want to have time to talk with people. About tokenization. Tokenization is hell on LLM development. Tokenization is something that, like, if I could speak hours just about tokenizers and how they are extremely annoying. But one of the things that we think we know, there's no concluding evidence about that. There's actually contradicting evidence on that. But many studies point that compression is usually can be correlated with tokenizer performance. So if your tokenizer is able to compress language, the better. You end up with a language model that is more efficient, not more efficient, better, but also more efficient, because if your tokenizer can compress language better, you have more context. Tokenizers, like for example the tokenizer of Llama 2, they are not very good at encoding languages like, for example, Portuguese. They take a lot of tokens because, if you're going to see the tokens that they have, the 32,000, it's basically sub-English words. And Portuguese is not like that. Like, like the token futebol doesn't exist on Llama 2 tokenizer. And futebol should be a token for a Portuguese tokenizer and a Brazilian Portuguese tokenizer. I actually don't know if it is for ours. Someone could check that. But, well, thinking about that compression is something important for tokenizer efficiency. How did we select our tokenizer? We basically conducted a test on over 28 different available tokenizers, trying to find for like what is the smallest tokenizer, like, that has like this, that will generate the smallest embedding matrix, because, a huge embedding matrix, like you have this like high computational cost when you're going to train the thing. So, what is the best of both worlds? It actually compresses languages and is not that big. Like, and we found that actually a tokenizer that we trained from a previous paper, which is called Teeny Tiny Llama. Teeny Tiny Llama is the paper that like preceded Tucano. This was our first attempt to train and actually build the pipeline for training an LLM in Portuguese. We saw that like this tokenizer is actually extremely efficient for reasons that up to this day elude my rationale. Like, because like everyone here who ever trained a tokenizer, you know how these things work, and it's like a pseudo random how tokens are minted, and it's very crazy that like sometimes you train a tokenizer and you change the seed and just performance goes down the drain. But luckily, Teeny Tiny Llama is a very efficient tokenizer, and we use it for the Tucano. So like, Teeny Tiny Llama and Tucano, they share the same tokenizer. Like, so if you have some text encoding with the Teeny Tiny Llama tokenizer, it will work on Tucano. You don't have to change anything. About architecture, we train a series of LLMs from 160 million parameters to 2 billion.4. Why did we train small language models? Like many people that have been talking recently, they have this very grandiose project that I want to train a 70 billion parameter model for Portuguese with your data set. And like, right, I always try to account, like, have you ever trained a small one? Have you train a billion parameter neural network? Because things, they change. Like, the challenges that we had when we were training, like, our 160 million parameter model, we didn't face when we were training the big version of Tucano. And we're scaling them, and we like right now for like our next series of models, we're thinking about going to 7 billion, because right now we already like kind of mastered how to train models at this scale. But I believe like, researchers, we should be incremental in our steps. I think if I would try right now to train a model that is way bigger than this, I would waste so much resources just making mistakes. And that's something from a sustainability perspective should be unacceptable. Also, when you train a series like this, a cool thing that you can do is to do all of your experiments, all of your tinkering and making mistakes with the small ones. And then when you finally know, now I know what is the good data mixture, I know what is the good rates, now I'm going to extrapolate all that I learned from my small ones to the big ones, and then you go. This actually does not, like, it's not the optimal way. The optimal way is always to tinker, implement, and search the space of possibilities when you're training something like a neural network with the neural network you want to train. But that is extremely costly. If I had ran the same amount of experiments on my 2 billion.4 model, if I ran the same amount of experiments that I did on the smaller model on the bigger model, our costs and computation and energy consumption would be so big. So like, you just like, we couldn't do it. So, and that's why we have scaling loss. That's why like we do things on a smaller scale, we project how is it going to be on the bigger scale, and then we go with our fingers crossed, hoping that everything would go right. And luckily in our situation, it worked out. Because it happens sometimes that like, you don't get your hyperparameters right, and the performance of your smaller model is X, and the performance of your bigger models is actually worse than X. And then you're like, what is happening? I made my model bigger, I'm training with more tokens, and it's actually worse than a small model. What am I doing wrong? So, and that's bad when those things happen. But luckily, didn't happen to us. Because I think we did a good job on evaluating and experimenting with the small models. These are basically our hyperparameters. I'm not going to go in detail on all this because it's a bunch of technical stuff, but we spent it, especially me and my colleague Aniket, we spent it From the 8 months that we took doing this research, we maybe spent 6 on just optimizing, making sure that the code could run as fast as possible. Because, you know, on our first predictions, on our first running code, we saw like, oh, we can train this big model with 500 billion tokens if we take a year. And we're like, that's unacceptable. People will laugh at our faces, that our code is very inefficient. And we took a lot of time writing something that was fast and could be comparable with other, like, you know, other results from the literature. And we got a pretty good model flop utilization. 55% is on par with most research like that is being done right now. And we were happy about this. Like, we got a really good throughput. And the cool thing is that like this code implementation is available. And like if you, for example, had access to a DGX server or something like that, you can run the code, and it's quite performant for these size of models. If you need to train something bigger, then you have to go for something like fully sharded data parallel or Megatron, which is the framework that we are using for our next series of models. About evaluation protocol, we had a mixed evaluation protocol that, like, if I'm not mistaken, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 evaluations. They are native for Portuguese. Most of the data sets that I'm showing to you guys right now, they are available on the Open Portuguese leaderboard. Okay, and also these translated benchmarks that they were made available by other researchers, and 2 that we introduced. The translation of Lambada and our own implementation of the Alpaca eval, they are contributions from our paper. So like we also brought new benchmarks for the community to use. Also in terms of alignment, like to make our models more easy to use, we took our two largest model, which is 1B1 and 2B4, and we implemented a fine-tuning process dividing in 2 stages: supervised fine-tuning or instruction tuning, and DPO. Okay. To basically make like our models, they had already, GigaVerbo has a lot of instructional and conversational text. So with minimal prompting, they already work. They really follow what you want. But, you know, it's easier if the thing is already optimized for chat. So we develop these things. For the supervised fine-tuning, we synthesize a small data set. It's 600,000 samples of user-assisted interactions. It's available on the hub. You can download. And for the DPO step, we use 35,000 triplets of prompt, preferred response, and less preferred alternative. And we designed a DPO with transform and reinforcement learning library, which is an awesome Hugging Face library. For those of you guys who are interested in alignment, alignment is actually my area of research. I did my PhD all about alignment. I have this is the shameless self-promotion part. So like my co-authors, sorry. I have a publication on this. Is a book that I intend to publish via Springer. And the name of this book, my thesis, is Dynamic Normativity, Necessary and Sufficient Conditions for Value Alignment. In it, I build philosophical foundations for alignment, and I also build language models using my theory, okay? So for any of you guys who are interested in alignment, I would stress you guys to go check it out, this work. I'm very proud of it. And it's very nice to see nowadays there's so much interest in alignment. I swear to you guys, when I was trying to get my PhD scholarship in 2019, no one cared. And it's very nice that nowadays people care. I feel very lucky that I chose to dedicate my academic life to this field. About results, like these are our learning curves. As I said, like sometimes it happens that the big model doesn't train as good as the small model, but this didn't happen with us. Thank God for so much experimentation. We were actually able to make, like, you know, develop a data set and a training protocol that scales. And you can see as the models become larger, perplexity goes down. And that's what you want to see. Result on benchmark evaluations, like for every, this is something that is very important. For every 10 billion tokens, we save a checkpoint and then we run our evaluation harness on it. This is vital because, like, you know, many studies, they only output the final benchmark evaluation. And that says from an analytical perspective, almost nothing. Because, a benchmark that randomly, it's not a very good benchmark. Like a benchmark that your chances of having a good result on that benchmark, they don't change if you were trained on 10 billion tokens and 500 billion tokens. What is it? What is this benchmark evaluating if not just overfitting? It just cares if you memorize its data or if you are fine-tuned on it. So, like, we did this evaluation harness on every checkpoint, and because we know how many tokens were trained in every checkpoint, we tried to make a correlation calculation between token ingestion and model performance. And this is actually extremely well made. Props to the people from the Gloria paper. This benchmark called Calami, it scales so well. All models, independent of their size, as you train, the model becomes better and better and better. And on this benchmark, we were actually able to be better than Llama models, like the Llama 3.23 billion, which is actually bigger than our biggest model, and it was trained on far more tokens than our model can outperform it, which is quite nice. But on the contrary, many benchmarks, they oscillate. They doesn't matter how much your model trains on it, it just doesn't get good. And I think the first person to point this out was the people from the Gloria paper. They pre-trained a language model on 30 billion tokens, and they saw that their model was actually quite bad on all of these benchmarks. And they were like, we fully don't understand why. And we were like, curious, why isn't that? We did the same thing, and we saw that regardless of how much our models train and regardless of model size, performance is pseudo-random. And that is no positive correlation between token ingestion and benchmark performance. So how can models be good at these data sets? We run some tests, and if you put some of the test data into your training data, then they become good, which suggests that it's overfitting. Maybe not overfitting, but sometimes train on template tasks that are severely similar to the evaluation benchmark. All of these data sets, they had either very low correlation or negative correlation, which is something that is bizarre. The more the model train, the worse it becomes. It's just better to take a randomly initialized neural network that is a random guesser, and they perform better than a model that was pre-trained on Portuguese. And that's so what did it mean for these benchmarks? I don't know. What we say here is that maybe they are not very good indicators for performance on Portuguese language modeling. But there are other benchmarks that are quite good. They scale, as models are training, as you feed them new tokens, you can actually see that there is a linear trend. They are becoming better and better and better. Lambda is one of them. Also, one of the benchmarks that we introduced, which is alpaca eval. When you take one of the models and you put them through an alignment process, they usually lose a bunch of the abilities that they had when they were just a base, and that is normal. Alignment, you can understand as mode seeking. So, and when you're mode seeking, you're basically you're cutting parts of the distribution out. So usually fine-tuned models, they don't perform as general as their foundations. That's why we have benchmarks specialized to evaluate how, for example, fine-tuned models for chat applications, how good they are. One of them is Alpaca. And Alpaca is basically an automated replication of the language model arena, where we use GPT-4 to rank model responses against a predefined golden standard. And we can see that our models, even though they are small, they are able to even outperform Llama models. Our Tucano 1B1 is actually, GPT-4 prefers its responses than the responses of Llama 3.21 billion. And Gervasio is a fine-tuned language model from Portuguese researchers. They use Llama 2 as a base, and they fine-tune it to be a Portuguese chat. And its replies are, according to GPT-4, horrible, extremely bad. A 7 billion parameter model is outperformed by like teeny tiny Llama. And we thought that was quite cool. Another point that we like to show in our results, part of the things that guided our project is this idea that we wanted to be as efficient as possible to minimize energy consumption and our carbon emissions. I have with me right now my colleague, Sophia Falk. She has this paper that she just published, which is called The Attribution Problem of a Seamlessly Intangible Industry. I recommend everyone to check it out because she talked about these things and she would talk much better than me. So if you have questions about that, you should ask her after I stop talking, which is about the side effects of deep learning practices when they are scaled at the level that right now we require when we develop these models. So with that in mind, knowing that like deep learning at the scale that we do here is extremely energy hungry, we did a basic sustainability practice that is to measure our carbon emissions and energy consumption using, of course, the carbon intensity of Germany as our marker because we are in Germany. All this training was performing on the Marvin cluster. If you have questions about the Marvin cluster, my other colleague, Aniket Sen, could happily reply to everything that you might have about the cluster. And long story short, we produce 6 tons of CO2 for this project. Even though, like, you know, we calculate like duration in hours, like how many kilowatts we expending for training, for experimentation. We try to minimize experimentation to the utmost. Like we try to minimize the best we could experimentation for our large models because experimenting with them was expensive. Not in terms of using the cluster because the use of the cluster for us is free, but in terms of like the energy we were consuming and the equivalent emissions. And there's a point here to be made that, like, you know, deep learning research is still extremely experimentationally and heuristically driven. Like we figure out what it works as we are doing. And even though that there are studies who try to document how things are done, and there actually are a couple, but not that many, which is a problem for the field. Like when we don't know how to do these things, like we have to constantly keep reinventing the wheel. So even that there are no universal solutions, if we had more documentation, we could narrow our search space to actually don't make so many mistakes. But because there are not like a truly open source development in LLM, there's not that much. What had happened to researchers like us who are also trying to learn how to do these things and like to create, to develop, we have to make a lot of mistakes and to reinvent the wheel. All the time we're reinventing the wheel of things that we know that other researchers that work under closed doors, they know, but that information is not put forward. And that is extremely that it's a problem that hinders scientific progress. And that is also extremely unsustainable. Like if I'm not mistaken, like almost 10% of our emissions is us making mistakes. So maybe there's like close to a ton of emissions that it wouldn't happen if we had access to good information about how to do this. But luckily, people who are going to base our work in our study, they will probably be much more efficient than us because they won't have to spend 6 months doing mistakes and optimizing code. And about costs, I know that there's a lot, I don't know, I heard that there's a lot of talk on the Brazilian government talking about like, is it possible for us to train LLMs? Like how much money would it cost? And I heard that there's a lot of talk that like, this is too costly for Brazil. This study costs taking aside my salary as a researcher, the salary of Sophia, Ani, and Shiza, just on compute, using the rate to rent an A100 on the cloud on something like Lambda, $6,000. It's not much. Me and Ani, as we were doing, me and Ani worked together a lot on this past 8 months, and I was constantly feeling like, someone will gonna publish something just like this tomorrow, because we're not doing anything too much. We're not doing anything too much because the cost, I don't believe that large Brazilian companies, they don't have $6,000, but maybe training models at this scale is not interesting for them, and everything that is interesting is something that is huge and big and can compete against ChatGPT, which I understand, but luckily that was not our intention. Now about future works, there are for people who are interested in developing models and keep this kind of work, there are numerous milestones for people working with Portuguese LLM development, and that if we achieve them, then maybe Portuguese will be high resource language. So this history of low resource language will be a thing of the past. First of all, we'll be expanding GigaVerbo by creating better data sets. We are currently working on that, on trying to introduce to GigaVerbo more high quality text, like academic papers, thesis, dissertations, all of native Portuguese. Of course, this is a problem because it's hard to get high quality text and filter it, but the field is progressing. There are a lot of cool tools out there that we are using, and we are slowly making a second version of GigaVerbo. Also, one of the things that we didn't do in the study and people could approach on future studies is adding synthetically generated data. Not because the synthetic data that we have, it was English, and then we translated for Portuguese. There is a lot of effort that can be put in trying to use state-of-the-art models to try to make high quality domain specific Portuguese text, like different dialects of different states in, for example, Brazil or Portugal or other countries like Angola, Cabo Verde, Mozambique. So there's a lot of things that you can do with synthetic data generation that we didn't explore. Also exploring the downstream applicability of our series. These models now, they serve to try a lot of things, like how good did they work if you fine tune them for the legal domain, for the medical domain, to making lavas, to making them multimodal, which is something that we're currently also seeking right now to train vision Tucanos. What else? Also increasing model scale. It might be that certain benchmarks, they only show performance if you increase your model up to a certain size. We are very eager to test these things, and our next range of models is 3 billion, 7 billion, and 13 billion, and slowly scale up until we train something like a 500 trillion parameter neural net using the force of the sun, something like that. And also try to develop new, more comprehensive benchmarks for Portuguese. The test that we did show that these benchmarks that we are using, they were not very efficient. So maybe what we could do, instead of just throwing them in the trash and not using them, is how can we reinvent them? How can we recycle these data sets so they correlate better with Portuguese pre-training? How can we change them and modify them a little bit so that they are actually good at evaluating the performance of Portuguese language models? So Tucano, what we tried to do here is there's a very nice paper that came out a couple of months or weeks ago about how do you define open source in terms of AI. And according to that paper, open source AI is not just open weights. It's when you have a development that outputs an open model, an open data, the code is available, the logs, the checkpoints, and this is something that we were able to do. Not just us, there are other researchers who also did this, but maybe we can say that Tucano, I don't know, maybe this people will come on LinkedIn and scream at me, but I think Tucano was one of the first open source language models that was trained on actually at scale. But I don't know. G-Portuguese also did that. I don't understand these things of people saying for example, no, G-Portuguese is not an LLM because it's too small. I don't know. When I was in doing my master's and everything, like BERT is an LLM. I don't understand this having like this cut, but well. Okay, this is the presentation. I hope you guys like it. I'm sorry if I started too much. It's almost 9 at night and I'm a little bit tired from my day. We hope this development had helped, like, Portuguese NLP community become like, our main goal is like to make the NLP, global NLP community more open, like, make resources more equitable and make the system more sustainable. These are the driving normative principles for our research. This is what we try to do here. And I hope to keep doing this for Portuguese, because I'm Brazilian and I speak Portuguese. And we also hope to replicate the study for other languages. There are other 7,000 languages that need their LLMs, and we hope that we can do this in our next studies. And that's it. Thank you very much. These are the emails of my colleagues. They didn't speak today, but if you have questions for them, please ask them and they will reply. And if you have questions for me, please ask me and I will reply.
Nicolas, Sophia, Aniket, and Shiza, thank you very much. Great work, congratulations. We have some time for questions and discussions with the online audience and the personal audience. Professor Marcelo raises his hand.
Hi, Nicolas. Thank you very much for your presentation. Very lively. I don't know where to start, but I'll ask one thing. If you add more and more data and the performance of your model doesn't improve, doesn't that mean that the data is crap?
Yeah, that could be. That could be. But, this is like one of the
of low quality. Okay.
Yeah, like for example, let's say one of our data sources was first thing I wanted to say, our research, if we put on the research paper everything we did, it would be a 200-page article. Is impossible. So when we did experimentation,
thesis or
yeah,
research report,
yeah,
not
too much.
a paper.
And like, for example, like a part of our data set is from the legal domain. It's called Legal PT, extremely high quality. Like, we filter it using like the filters, GPT-4. Almost all of that data set is considered high quality. And we took that data set and we trained, like we did ablation studies, like for example, take just that data set and train the model, fine tune it on it, see if it's good on the OAB exams. Random performance, complete random. So like, being trained on just legal text does not make you good at the benchmark that was meant to evaluate your legal domain. But if I take all of those questions from the OAB exam that are on a test set and I fabricate synthetic data from it, like, I give it to ChatGPT, hey, here's an example of my question, make 20 of this to me. And then I train the model on that, then they start to become really good. They start to become really good. And then as a researcher, you start to think, what is more probable that is happening for models that have this high performance on these benchmarks? Do they have access to some unknown high quality legal text that is unknown of, or they are actually, they are overfitting to the distribution? I could told you, like, this is an empirical question. There is a way to find that out. Unfortunately, we cannot, because we have not the data disclosure of many of these models. We don't know how models like, I don't know, Llama or Mistral are trained. If I had, there was an empirical question, then you can say, no, GigaVerbo is shit. But 70% of GigaVerbo is considered high quality, according to filters that were trained with the assistance of a very, very good language model. So I don't know if it's that crap,
Okay, well, there is a lot of things that need to be done, but just one thing from the beginning. You said that the people need to know how to train these large language models from scratch, and then you start saying that, well, we fine tune, then you don't really know how to do that. That's false for most of those models, because take Bertinbaum, for instance. They can be
I'm
trained.
sorry, I'm gonna have to turn on my light. I don't know why my light just went off.
Sorry. Oh.
I hope there are no ghosts here.
No, I thought there was a blackout in your office. Anyway, sorry, but the problem is the difference from training, say, Vertimbau from scratch, or how they did it, is just the initial model. Like they started with the initial, so there is no question that they know how to do it from scratch. It's absolutely the same thing. They just realized that at that time, for those resources, they would get better research results starting with the pre-trained, with the model already trained, like the multi-language model they did, and then you add up a little bit of Portuguese, and it's better than training from Portuguese from scratch. Doesn't mean they don't know how to do that. It means that was their best result. So
I don't know. I fully don't agree with that, because, for example, if that's the case, like I know how to train a language model from scratch that gets 80% on MMLU. That doesn't involve overfitting the test distribution. I don't know how to do that. I don't know what kind of data that I need. So like if you take a foundation, when I say like a training, just training the PyTorch loop is irrelevant. Many people know how to do that. That's not the question. The question is, do you know how to prepare data that will output in the training of a model that is extremely performant on things like OAB exams? Can you do that from scratch? Because then you show that you can do it. But no, I can only do it if I take a Llama and then I do it a little bit of Portuguese on top, because the Llama is already performant on everything. Like, is your Portuguese intervention actually helping? Maybe a little bit. On the case of Gervasio, it actually hindered. Llama 2 without fine-tuning of Portuguese is better at all Portuguese benchmarks than Gervasio. So in that case, it actually made it worse. So I don't agree with your point. I don't agree that like you actually know. Like
no. So you didn't define well what you mean by training.
Okay.
So you better be more clear then. Thank you.
You're welcome, Professor.
I think we have some questions here. Nicholas, in one of your slides, you used the term maximum likelihood, which suggests the use of a statistical model. What is this model, if there is one?
What slide did I use maximum likelihood? I have no idea what slide you're talking about, brother.
Maybe the filtering of the data set, Nico.
The filtering of the data set? Let me search. Thanks, Annie. Where's the filtering? Maximum likelihood. Not finding. Not finding. I don't know. I don't remember using this term, and I'm trying to find a slide that I use this term, and I don't know. What I can tell you about the filtering is that we trained filters. We took, like, we had two approaches. We turned text into embeddings, used the embedding vector to train like XGBoost classifiers. That didn't work very well because I think the embedding model was not very good. And then we did it with Birchbow. It was actually pretty good because Birchbow is the GOAT. Best language model ever.
Anyone here? Pedro, go ahead.
Hi, I'm Pedro from NVIDIA Latin America. Congratulations, Nicholas, for your presentation, your hard work, you and your team. I'm supporting the development of sovereign AI LLM models in Latin America, and I have a special interest in Portuguese and Spanish. And I'm working with my colleagues there in Europe that are supporting initiatives there same for Spanish and Portuguese. And I have a couple of questions. The first one is if you have tried the NVIDIA framework called NeMo for training LLMs, and have heard about that. Maybe you can, or my impression was that you implemented everything from scratch using PyTorch or TensorFlow.
Mhm. Yes, like our code base is all like made by hand. We did the PyTorch like training script, but we didn't write the kernels of PyTorch. That we didn't do, even though sometimes Ani wanted to do. But yeah, we did everything with PyTorch. NeMo, I know by name. I don't know by using it. What I know from NVIDIA is Megatron, and Megatron like being like standard library for developing like very big models on like multi-node systems. That is the framework we're envisioning to keep doing our research. But thank you for the advice. We will check NeMo.
Oh, okay, great. And that was my second question about the computational power you have access. You mentioned DGX A100. Did you use several DGX or just one?
I can show you just a second. This is the specs of the cluster we use. I'm going to put in the chat, and it's easier. It's easier if you read. But like for
Okay.
the small model, for the big models, we use 4 nodes. 4 nodes. And now
4
we are
nodes.
like for training bigger models, we want to move away from our home cluster and start using something more powerful like the Ulish cluster that we have close by, that is like an exascale supercomputer. And that is like what, like, Ani, you want to say something?
Yeah, it's not exascale.
Jupiter is not exascale?
But I don't think we'll get access to Jupiter at the moment.
But you have access. Give me access.
Maybe not for this project, but yeah, okay.
Okay. The exascale part is just for Ani. Sorry.
No GPU fighting, guys. Okay. My question: do you have any support do you have any support at NVIDIA in Germany or Europe in general? Are you connected with the guys at NVIDIA?
Ani, are you?
So, yeah. So I do not, in principle, work in machine learning. So I work in physics with something called lattice QCD. So I do have connections with NVIDIA, but more on physics side, not really on machine learning side. So I also contribute on something like CUDA, which is a NVIDIA software. But yeah, so that's my connection to NVIDIA. So I don't have any connection on the machine learning side.
Okay, guys. Me and Fabio here, my friend, we are getting contact with you and also with USP. So maybe we can join forces in this endeavor to build LLMs for Latin language like Portuguese and Spanish, and give back to the community.
Sure.
Okay.
Give us compute, we give you models. That sounds awesome.
Deal.
People are asking about the computer you use it. Great work that Sophia did measuring all the kilowatts and stuff. Can you tell us about the infrastructure you have at the University of Bonn?
I think the best person to talk about the infrastructure is actually Aniket, because I'm going to start speaking and then I'm going to make a slight mistake and then he's going to actually. So Ani, prevent me from saying mistakes and talk about Marvin.
Okay, thank you. So the cluster that we're using was recently made available at the University of Bonn. It's called Marvin, and it's technically quite a small cluster, but it is part of top 500, or at least it was when it was first announced. So the cluster that we're using, so it has special partitioning for machine learning applications. But we use the scalable GPU partition, which has this A100 GPUs, because that has more VRAM and also quite a bit higher performance compared to the machine learning partition, which uses A40s. So the cluster at the moment, it has this scalable GPU nodes with 4 NVIDIA A100 80 gigabyte GPUs, and 2 EPIC Milan 64-core CPUs. And if I remember correctly, for our largest model, we used 4 such nodes, so 16 GPUs to train on.
Perfect.
Thank you very much. Someone
For the
wants to ask Portuguese, feel free, because Nicholas can understand. Maybe you would.
Eu falo português. But I do.
Go ahead, Hugo.
Hey, Nicolas, Sophia, it's great meeting you again.
Yeah.
Actually, so first of all, congratulations for the work. I was really was looking for the paper, and I'm really not disappointed at all. So great work. But I'm very curious about what are the next steps you are thinking about, guys. So are you thinking to keep developing this models to a larger size, or are you, I don't know, looking for something slightly different, like as we talked back in Portugal, like constitutional model, like fine tuning some layers and see if you can get anything different. So I would love to know what you're thinking about for the future.
Yes, for the near future, I hope very soon, like maybe in December or January at the most, we're going to be releasing vision models. So like, models that like it will be the first multimodal models for Portuguese natively pre-trained. So like you can feed them image and they tell you, there's a cat there. We're releasing that, and of course with the data set, with the code, like people can reproduce, they can replicate. This is one of the things. The other thing is scaling. GigaVerbo right now, without any addition of tokens, it can be used to train much larger models. Like according to scaling laws, like the rule of 20 tokens per parameter, we could train larger things. And also, since we published GigaVerbo, there have been new published Portuguese portions of Common Crawl. I want to get all of them, filter, edit. So training larger models and making our data set bigger is on the menu. And maybe that doesn't interest you guys, but we want to go for other languages because like we would like to do the same kind of development because Portuguese is actually right now it's much better than it was 2 or 3 years ago. But like there are languages that don't have a single benchmark. They don't have like like a 2 billion tokens, and it would be very nice to try to help these people because like the idea is not just to make Portuguese as good as English and Chinese and then they dominate, but like I want to keep pushing Portuguese because that's my language and I have like this interest in Portuguese, but I would also like to dedicate my efforts to areas where like I would actually make more impact, like for other languages. Like I've recently been in a conference in Cairo in Egypt talking about trustworthy AI for the African continent, and I was able to meet a lot of young AI researchers struggling with the same things that I was struggling 5 years ago. Like they're trying to train their LLMs on their own languages, and they're finding the same barriers. And I was like all the time, email me, talk to me. I think I can get compute to do these kinds of things. I can help you guys do it. And I would like to dedicate some of my time and effort to helping these other communities. But yeah, that's what I imagine on the long run.
Someone
All
else?
right, great.
Guys, I think we don't have more questions. I would like to thank you again for sharing your work and taking your time to present the research for us. I think that we're gonna upload this video on our YouTube, and let's keep in touch, maybe build some partnership. It was great to hear from you before.
Thank you, Professor. And like it was so nice to meet you in Azores. It was like a wonderful opportunity of networking, and I hope we can definitely do more things together. Like I miss my home country. So thank you very much for the invitation also.
You have been doing a great work. Everybody here is amazing. Thank you very much.
Thank you,
For
everyone.
the audience, to online audience. And here we have our audience. If you want to see them, say hi to them.
Ooh, hi, people. Ooh. Oh my God, I'm sweating. I was so nervous.
It's summer.
But okay, then good night, everyone. I'm gonna go
Bye
take
bye.
care.
Thanks for having us. Bye.
Bye-bye.
Thank you. Bye.
Bye-bye.
Thank you. Bye.